The X-44 Manta is changing the game. Unlike the loud jets of the past, this aircraft is built for silence, speed, and stealth. It can appear and vanish before radar catches it, making older warplanes look slow and outdated. As global tensions rise, countries are racing to develop the most advanced aerial weapons. But the United States is pulling ahead, creating planes so futuristic they seem straight out of a sci-fi movie. So, what makes the X-44 Manta so special? And why are China and Russia paying close attention? Join us as we break down the cutting-edge technology behind America's newest stealth fighter and why it could reshape the future of air combat. Flying without a tail might sound impossible, but aerospace giant Lockheed Martin once dreamed exactly that. Their extraordinary concept, the X-44 Manta, an acronym for Multi-Axis No-Tail Aircraft, wasn't just another military plane design. It represented a complete rethinking of how aircraft could move through the skies, promising maneuvers that would make even eagles jealous. A perfect example is driving a car without a steering wheel, controlling it solely by changing how the engine pushes the driver forward. The Manta achieved something similarly revolutionary in aviation. Scientists of the National Aeronautics and Space Administration and the United States Air Force studied this wingless wonder seriously, believing it might unlock aerial movements previously thought impossible. Directing its thrust in 3 dimensions, up, down, left, right, or any combination. Born from the already impressive F-22 Raptor, this tailless marvel featured a stretched delta wing that resembled a giant arrowhead cutting through clouds. What made it truly special was what it lacked, the familiar tail fins on virtually every airplane. Without these stabilizers, the Manta would have relied entirely on adjusting its engine thrust to control its movement, like balancing on a skateboard purely by shifting weight, but at supersonic speeds. In May 1999, the National Aeronautics and Space Administration and the United States Air Force quietly started working on a bold new aircraft project. The goal was to test new flight technologies without using the traditional tail found on most jets. These new features were meant to improve stealth control and performance in the air. NASA hoped to try them out on an F-22 Raptor or even an older F-15 fighter jet. They expected the prototype to begin test flights by the year 2007. NASA believed that the work done on the X-44 Manta could help improve not just military jets like the F-22 and the future Joint Strike Fighter, now known as the F-35, but even faster passenger planes for the public. At that time, engineers were thinking far ahead, dreaming of aircraft that could fly faster, quieter, and with more control than anything that had come before. The government and 2 private companies paid for the project's first steps. Then in June 1999, NASA officially gave the green light and named the aircraft the X-44A. It was an exciting moment in aviation history, as many believed this plane could lead the way into a new era of flying machines. But just 1 year later, funding was cut and the program was shut down before the aircraft could take flight. However, the ideas didn't completely vanish. Some of the designs in later years, like the proposed FB-22 bomber, were inspired by the same no-tail concept. In many ways, the X-44 Manta's legacy remains in the quiet, powerful jets flying today and maybe even in the next generation of drones and stealth fighters. When engineers dream big, they don't just aim to improve. They seek to rewrite the rules completely. The documents for the X-44 explicitly call for an aircraft that would leapfrog state-of-the-art, much like how a smartphone didn't just improve the flip phone but fundamentally change how people communicate. Lockheed Martin's ambitious goal was simple yet profound. Prove that an airplane could fly perfectly well using only the direction of its engine thrust or control, throwing out centuries of flight control procedures. The X-44 Manta would have been harder to spot on radar screens because it lacked the vertical fins and tail surfaces that typically create distinctive radar reflections. Think of how a smooth stone skips better across water than a jagged one. The Manta applied this principle to radar waves. By removing these traditional control surfaces, the design became stealthier, more streamlined, and more efficient, using less fuel to travel farther. The DNA of the F-22 Raptor ran strong in the X-44, sharing the same powerful engines and body structure. However, the Manta transformed this foundation with its striking delta wing shaped like a triangle pointing forward and a complete absence of tail sections. The benefits of this radical approach would have been substantial. The larger triangular wing meant the Manta could carry more fuel than its F-22 parent, allowing it to patrol longer or strike deeper behind enemy lines. By merging control and propulsion systems into one integrated solution, Lockheed Martin aimed to create an aircraft with fewer moving parts to brake, better fuel economy to extend range, and stunning agility that could make traditional fighters look like they are moving in slow motion. Like a boxer who can dodge punches while barely moving, that's the kind of efficiency and responsiveness the X-44 Manta promised to bring to aerial warfare. The X-44 Manta earned such a distinguished reputation that Lockheed Martin developed another aircraft sharing part of its name, the Lockheed Martin X-44A. This lesser-known cousin is an unmanned aerial vehicle technology demonstrator created by Lockheed Martin's legendary Skunk Works division. Unlike traditional aircraft, the UAV operates without human pilots, crew members, or passengers on board. Instead, these sophisticated flying machines are controlled from a distance or programmed to navigate autonomously, representing a significant advancement in aviation technology. An unmanned aerial vehicle or unmanned aircraft system, commonly called a drone, is a flying machine that operates without humans on board. Instead of having pilots sit in a cockpit, these aircraft are either controlled by someone from the ground using remote controls or fly on their own using pre-programmed instructions. In the 1900s, militaries worldwide developed drones mainly for missions that were too boring, dirty, or dangerous for human pilots. Imagine flying for hours over an empty desert just to see if there are suspicious movements. That is a tedious job perfect for a drone. By the early 21st century, armies everywhere considered drones essential equipment, using them to gather information and carry out missions without risking soldiers' lives. As control technologies improved and production costs decreased, the application of UAVs expanded beyond military use. Today, unmanned aircraft serve countless civilian purposes, including capturing breathtaking aerial photography that once required expensive helicopter rentals. They monitor vast agricultural lands, helping farmers make precise decisions about crop management. The Advanced Tactical Fighter program aimed to create a fighter jet that would dramatically outperform anything before. This new aircraft would use cutting-edge technologies, including sophisticated computer systems, more powerful engines, and special materials that made it nearly invisible. In 1986, the United States Air Force chose two companies, Lockheed and Northrop, as finalists to develop prototype aircraft. Each company would build test planes, the YF-22 and YF-23, to show their ideas in action, and these test planes took to the skies in 1990. After careful testing and evaluation, the Air Force selected Lockheed's design in 1991 to advance into full development. This process, called engineering and manufacturing development, would turn the experimental aircraft into something that could be built in numbers and used in real-world operations. Lockheed's winning design evolved into what people now know as the F-22 Raptor. The F-22 Raptor became the Air Force's premier fighter jet. It combines stealth technology, making it hard to detect on radar, with incredible speed and maneuverability. This gave American pilots a considerable advantage in the sky, as they could see enemy aircraft before being seen themselves. Beyond its primary test goals, the X-44A supported other important projects. In one particularly interesting test, the drone demonstrated how unmanned aircraft might operate on Navy aircraft carriers. Landing on a moving ship at sea is one of aviation's toughest challenges, even for human pilots. So testing these capabilities with a drone represented a significant advancement. These carrier tests helped pave the way for today's carrier-capable drones. What makes the X-44A story so fascinating is how Lockheed Martin developed a significant aircraft completely out of the public eye. While defense companies often work on classified projects, keeping an entire aircraft program secret for almost 2 decades is remarkable. The Manta is an important missing link in drone development, connecting early unmanned aircraft experiments to the sophisticated drones around the world today. Its technologies have influenced numerous current and future aircraft designs, showing how these flying laboratories help advance aviation, even when people don't know they exist. The X-44A is built from nanocarbon fiber, a lightweight but extremely strong material similar to what's used in high-end bicycles and tennis rackets. It runs on a Williams F1 12 turbofan engine, which works like a miniature version of what powers commercial airliners. What's striking about this drone is its size. With a wingspan of just 30 feet, about the length of a school bus, it's half as wide as its larger cousin, the RQ-170 Sentinel. This compact design made it easier to transport and less visible to radar, which are important features for military aircraft. Despite its small size, the X-44A packs impressive capabilities. It could reach up to 176 miles per hour, faster than most highway speed limits, making it quick enough to cover large areas on reconnaissance missions. The drone could stay in the air for 1.5 hours on a single fuel load. While this might seem short compared to today's drones that can fly for days, it was enough time to test new technologies and gather valuable data without needing a human pilot on board. Aviation enthusiasts and history buffs can now see this one secret aircraft in person. The X-44A found its retirement home at the National Museum of the United States Air Force near Dayton, Ohio. Located in the Research and Development Gallery inside Building 4, this mysterious drone was finally put on public display in October of 2020. After decades of being hidden from the public's view, visitors can now appreciate this important piece of aviation history. China and Russia are paying close attention to America's X-44 aircraft concept. Both countries are working hard on their military planes, but a comeback or update of the X-44 would give the United States a big advantage in the skies. China's Chengdu J-20 and Russia's Sukhoi Su-57 are their best stealth fighters, but neither uses the same wingless design as the X-44. If America decides to bring this concept back, it could leave these competitors behind in stealth, maneuverability, and battlefield awareness. China is currently developing its next advanced stealth fighter, which might be called the J-25 or a version of the J-31. Their goal is to match American air power. Meanwhile, Russia is working on the Su-75. Russia showed off this fighter jet with big claims. They said this new fighter jet would match the American Manta but cost less. At its first public display, the jet looked sleek and modern. But there was a problem. The Su-75 has not flown yet. Several years after Russia announced it, the jet is still just a prototype, and no one knows when it will actually make more of them. This delay makes people wonder if Russia can keep its promises about the jet. Russia's defense budget is tight, and sanctions mean they can't get some of the important parts they need. These issues make it harder for them to finish the Su-75 and start building more. Another problem is its ambitious marketing. The Russian fighter jet was advertised as a low-cost fifth-generation fighter for export. But without proven performance or real battlefield testing, many countries are hesitant. Experts also point out that the checkmate lacks key stealth features found in more advanced aircraft like internal weapons bays and engine masking. For now, the Su-75 is more of a PR tool than a real challenge to American or Chinese air power. Until it flies, performs, and delivers, the checkmate is still just a promise on paper. Another jet Russia is boasting about is the Sukhoi Su-34, known as fallback by NATO countries, which is an aircraft that combines fighter and bomber capabilities. It's built for all weather conditions and can fly at supersonic speeds while carrying weapons over medium distances. Although it first flew in 1990 during the Soviet era, it didn't officially join the Russian Air Force until 2014. The Su-34 comes from the Su-27 flanker family, which was originally designed for air combat against other planes. What makes the Su-34 special is its wider cockpit with protective armor. Unlike most fighter jets where pilots sit one behind the other, this plane places its two pilots side by side, similar to how people sit in a car. Russian engineers designed this aircraft mainly to attack ground and naval targets. It can carry out bombing missions against large fixed and small moving targets. The plane works in daylight or darkness and can operate in bad weather and hostile environments where enemies might be using jamming equipment or shooting back. Besides attacking targets, it can also perform reconnaissance missions to gather intelligence. The Su-34 Russian fighter jet uses a special design with wings in 3 places, main wings in the middle, small wings up front called canards, and horizontal tail wings at the back. Think of it like a bird with extra control surfaces. Those front canards do 2 important jobs. They give the plane more lift, like adding extra muscle, and make it more agile, like a gymnast versus a weightlifter. This powerful fighter can carry an impressive arsenal, 12 weapon stations holding between 26,000 and 31,000 pounds of bombs and missiles. That's about the weight of a city bus. It keeps a 30mm Jisha 30-1 cannon from earlier models. It can carry 6 air-to-air missiles, mainly for self-defense if enemies approach from behind. The heaviest single weapon it can carry weighs 8,800 pounds, about as heavy as a full-grown elephant. The fighter jet comes with impressive dimensions. It stretches 76 feet 7 inches long, about as long as 7 tall adults lying head to toe. Its wingspan reaches 48 feet 3 inches across, similar to the width of a basketball court. When empty, this massive aircraft weighs 49,600 pounds, roughly the same as 6 full-grown elephants. At maximum takeoff weight, it tips the scales at 99,428 pounds, heavier than a fully loaded semi-truck. 2 powerful Saturn engines give this beast its thrust, each providing 30,000 pounds of force when using afterburners. This jet can reach extraordinary speeds. At high altitude, it can fly at 1,200 miles per hour, 1.8 times the speed of sound, or fast enough to travel from New York to Miami in under an hour. Even at sea level, it manages 892 miles per hour. The Su-34 typically cruises at 810 miles per hour, about 3 times faster than a commercial airliner. With a full weapons load, it can fly 680 miles from base and still return safely, covering a round-trip distance roughly equivalent to flying from London to Paris and back. Without weapons on long-range missions, it can travel up to 2,800 miles on a single fuel load. Regarding altitude, the Su-34 can soar up to 56,000 feet, more than 10 miles high, where commercial planes typically fly at just 6 to 7 miles. The aircraft can handle 9 times the force of gravity during maneuvers. Hence, the pilots experience pressure n times their body weight, enough to make most people black out without special training and equipment. The powerful engines of this jet give it a thrust-to-weight ratio of 0.68, providing enough power for impressive climbing abilities and maneuverability despite its heavy frame. For weapons, the fighter jet comes equipped with a Gryazev Shipunov Gsha 30-1 autocannon with 180 rounds of ammunition. This cannon can fire large shells capable of piercing light armor. The aircraft also features 12 attachment points on its wings and body that can carry between 26,000 and 31,000 pounds of weapons. These can include various rocket pods and missiles, the B-8 pods that fire 20 S-8 rockets, B-13 pods for 5 larger S-13 rockets, and sophisticated A-M missiles like the R-73 and R-77 for defending against enemy fighters. This extensive arsenal makes the Su-34 one of the most versatile combat aircraft in Russia's military lineup. The Su-34 has several problems. First, it is built on old Su-27 designs, making it hard to add new technology to the jet. It also does not have stealth features like newer jets. This means radar can easily spot it during missions, which is dangerous in modern war. The Su-34 is also very big and heavy. While it can carry many weapons, this extra weight makes it slower and less nimble than other jets in close combat. The world's big military powers, Russia, the United States, and China, are engaged in a contest they never discuss openly. Every new fighter jet, missile test, or space launch is part of this competition. These countries say they are just updating their equipment, but their actions show something else. When America develops something like the X-44 Manta aircraft, China and Russia quickly work on their versions to keep up. It's a high-stakes game of follow the leader that shapes military technology worldwide. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.